Dear students, I welcome you for the today's lecture related to the classification of pressure vessels part 2. This is the second lecture. Now in the classification of pressure vessel, that is based on the geometric shapes, uniformity of the shape, installation method, then the presence of internal pressure bearing situation, and based on the wall thickness. Up to this section we have already discussed in the previous class. Now today we are going to discuss related to technological process functioning based on the operating temperature, design pressure, then manufacturing method, manufacturing materials, and usage mode and the end constructions. Based on geometric shapes, it can be the sphere, cylinder, cube, rectangular, square, conical or trapezoidal or kettle type, that can be of any shape. Out of that, the spherical vessels, which are the and the cylindrical vessels, which are most commonly used. In addition to that, the sometimes the rectangular vessels, that is also used. Conical generally preferred for bottom sections for the easy solid flow. Then the combined vessels, that is the combinations of different geometries or dimensions of the same geometry. Then based on the uniformity of shape, that is the uniform shape pressure vessel and non-uniform shape pressure vessel, that is based on the dimensional variations as well as the change in the geometries also. Then based on installation method, that is vertically installed or horizontally installed, that is the different categories, or sometimes the inclined can be used depending on the process requirement. Then based on the presence of the internal, that is with internals and without internals. When it is without internal, generally it is the drums and tanks that is used, and with internals almost all our chemical equipments, that is your distillation column, reactors, heat exchangers, absorbers, and all other things. Then based on the pressure bearing situation, that is whether it is low pressure vessel, medium pressure vessel, high pressure vessel, or ultra high pressure vessel. Then based on the wall thickness, the pressure vessel according to their dimensions may be classified as the thick wall and the thin wall vessels. Now if it is the depending also on the thickness of a shell, if it is less than 1/10 of the diameter of the shell, then it is the thin shell vessel. That means the thickness is dependent or related to the vessel diameter. Now if the vessel diameter, if the wall thickness is less than 1 upon 10th, say for example if the vessel diameter is say 1 meter. Now for 1 meter vessel diameter and the vessel thickness, that is 1/10th, then it will be the thin shell diameter. Now if the vessel diameters is greater than 1 upon 10th of the diameter, then it is said to be the thick shell vessels. Besides that, the based on the stresses, there is the another type, that is if the internal fluid pressure is less than 1/6 of the allowable stress. Internal fluid pressure, if it is less than 1/6 of the allowable stress, then it is called a thin shell. And if the internal fluid pressure is greater than 1 upon 6 of the allowable stresses, then it is said to be the thick shell. Then thin shells are used in the tanks and pipes, whereas the thick shells are used in the high pressure cylinders, tanks, guns, barrels, etc. Now coming to the based on technological process or the functioning of that vessel, whose purpose of that vessel, whether it's a reaction vessel, whether it's a distillation column, whether it's a heat exchanger, all these are vessels. The internals may be the different, उसका जो housing है heat exchanger का, that is nothing but a cylindrical section. So reaction vessels, these vessels are used for carrying out the certain reactions. The capacity of the reaction vessel may range from smaller size as the 50 liters to 2000, 2 lakhs 500 liters, huge capacity. They can be made of steel, glass or glass lining, or sometimes ceramics that can be there. Then these heat exchangers vessels are usually horizontal and are easy to clean and repair. They are widely used in chemical industries for heating or cooling purposes. Then the separation vessels. In this separation vessel, one mesh that is available inside that, and which is impingement to whatever there the accumulated will be, that will be taken out from this mesh. So gases will go out and the liquid is taken out from the bottom depending on this level. So this is the separation vessel, separation related to gas and liquid. Then the storage containers, that is your LPG storage or ammonia storage, then kerosene storage, whatever it may be, the storage. All chemicals, they can be stored. Now, based on the operating temperature. Now, this temperature and pressure, they are the most important parameters for designing purpose. And based on this pressure, and we are calculating the thickness, and based on your temperature and the corrosive nature of the fluid, we are selecting the material of selection. So that can be the low temperature vessels, that is below the 20 degrees Celsius, below minus 20 degrees Celsius, and then the normal temperature vessels, that is say minus 20 to 150 degrees Celsius, that is considered to be the normal temperature range. Then the medium temperature range, that is 150 to 450 degrees Celsius. Then the high temperature range, which is more than 450 degrees Celsius. It is not specifically or characteristically distinguished, but however, this is the crude temperature ranges one can say. One can talk about 150 degrees for normal temperature ranges, 150 degrees or 200 degrees Celsius up to, that can be also taken as the normal temperature range. Then depending on this temperature, one has to select the material of construction, that is the wall temperature. If the carbon steel and low alloy steel, then the temperature should be greater than 420 degrees Celsius. Alloy steel, that is more than 450 degrees Celsius. Austrian steel, that is still greater than 550 degrees Celsius. So depending on the temperature range, I am going to have the selection of material. Then similarly, based on the pressure, that is the low pressure vessel, medium pressure vessel, high pressure vessel, and ultra high pressure vessels. So these low pressure vessels, that is 1 kg to 16 kgs per centimeter square, that is the range, or you can call the 0.1 megapascals to 1.6 megapascals. Or in case you say atmospheric, that is 1 atmosphere to 16 atmosphere or 15 atmospheres, you can call generally, either it is 15 or 16 people talk about. Then the medium pressure ranges, that is say from 16 atmospheres to 160 atmosphere, to 100 atmospheres. And then for high pressure vessels from 100 atmospheres to 1000 atmospheres, and for ultra high pressure, that is more than 1000 atmospheric pressures. So depending on this pressure, the low pressure, medium pressure, high pressure and ultra high pressure vessel designing has to be taken into consideration. Then based on manufacturing method, how that vessel is manufactured, whether it is simply welded or whether it is a forged vessel, forging, casting, then it can be the multiple walled vessels, then multiple wrapping that can also be there, that is the band wrapping also can be there. So if it is a welded vessels, these are the vessels that are fabricated by process of the welding, and which is the most common. Doing a vertical joint, doing a vertical welding in a sheet. If it is the sheet, I am going to bend that and having been welded vertically. So this is the most common uh, way of fabricating the vessels. Then forged vessels or casted vessels are there. These are the vessels that are fabricated by the process of forging or casting. Casting in old days, before the casting was preferred, that is, you are going to give the desired shape by pouring the hot metal into the cast. Then there is a multi-walled vessels. Multi-walled vessels are those which have the shell and heads made up of two or more separate layers. So these multi-walled vessels are those which have the shells and heads made of two or more separate layers. Means one layer is of can be of one metal, and the another that can be also the another metal, or can be of the glass. That is, you call it a multi-walled vessels. Then multi-walled wrap vessels. So you are going to wrap one sheet over the another. So if this is the one sheet, then I am going to have the given the curvature for this, and again I am going to wrap the second sheet over that. So it's a multi-walled wrap vessel. In this vessel, the thin plates are wrapped gapless, and that is and this the layered section forms a virtually solid wall with the uniform properties. Then the band wrap vessel. That means you are wrapping with the wires or the tapes. So band is wrapped and tight around the outer circumference of the neck portion at the location adjacent to the dilated portion, and its ends are engaged to secure the band in place. So the certain provided that it should not move or lose its position, so that the wrapping should be the perfect one. Then based on manufacturing material, the pressure vessels may be made of vertical material, various materials such as the steel, then non-ferrous steel, that is your ferrous, then non-ferrous, non-metallic materials also, that can be provided with a certain lining, either glass or ceramic lining, that depends on your process requirement, or sometimes your polymer lining also, Teflon coating, that is also used nowadays. Generally it's the steel vessels, their most preferred one. The many pressure vessels, that is made of the steel, to manufacture a cylindrical or spherical pressure vessel which are rolled and possibly forged parts would have to be welded together. That is, some mechanical properties of the steel achieved by rolling or forging could be adversely affected by welding unless the special precautions are taken. In addition to adequate mechanical strength, the current standards dictate the use of steel with a high impact resistance. In the category of steel, there are again the subcategories, that is 308, 304, 316. So all these are the different types of the steels, and depending on the end use and application, one has to select the desired qualities of that steel, whether you require high impact, whether you require a certain specific corrosion resistant related. That means and these are depending on the uh, material of construction, that is the different metals which are added, whether the chrome, whether the molybdenum, how much percentage of iron is there. Depending on that, the different types of the steels, they are classified. Then the non-ferrous vessels, that is the non-ferrous vessels, or sometimes they are also called as the only the pure metals or the alloys that can be used other than the iron. Iron is absent in this case, that is non-ferrous vessels. That is used mainly because of the desired properties that they have. The lightweight, for example, in case of aluminium, lightweight of the non-ferrous metal, then higher conductivity, non-magnetic, non-ferrous vessels are very resistant to the corrosion. So mostly it is the copper or aluminum or the alloys of copper and aluminum, that is your tin and other different alloys that can be used. Then the non-metallic vessels, in that the concrete, glass vessels, then plastic vessels, nowadays fiber reinforced vessels, they're also constructed and are regularly being used in the process industries. Then based on the usage mode, whether it's a fixed pressure vessel or whether it is a mobile pressure vessel. Now, almost all vessels which are there in the industries, they are the fixed pressure vessels. They are concreted to a certain place, and all the pipelines, they're rigid pipelines, fixed pipelines, which is not very easily and conveniently removed on regular basis. However, in case of mobile pressure vessels, that is the truck, which are based or located on the trucks or on the railways. So they are called as your mobile pressure vessels, and even your LPG cylinders, which are mobile, considered to be the mobile pressure vessels. So one thing is shown in this figure, that is the mobile pressure vessels are the vessels which can be moved from one place to another according to their requirement. Sometimes in case of pharmaceutical industries also, there is a flexibility of the interchanging of the vessels, that is also provided, because they are producing one chemical or one drug to a small extent, and again depending on the situation or depending on the market requirement, they are going to change the production rate and production capacities. The next, based on the end construction, the open end vessels and closed end vessels. Mostly it is the closed end vessels which are used in the chemical industries, so that the vapors of the chemicals, vapors of the valuable chemicals, that will not go to the atmosphere and will avoid the contamination in the atmosphere. But the open end vessels in which the water is generally the solvent, or which are not affecting the environment, only such chemicals that can be used. A simple cylinder with piston is an example of the open end vessels, and due to the fluid pressure, circumferential or hoop stresses, they are induced in case of the open ended vessels. So it's generally the drying processes or evaporation processes, they are carried out in the open vessels. And also these are the open vessels which are shown in this figure. It is attached with your gearbox and the motor.